Can humanity harness the full power of its planet? In the Kardashev Scale, a system for classifying civilizations based on their energy usage, Type 1 represents the starting point for civilizations that have achieved extraordinary power. But what does that really mean? And can humanity rise to this level? Definition of a Type 1 civilization. A Type 1 civilization on the Kardashev scale is defined as one capable of harnessing and utilizing all the available energy on its planet. This includes leveraging every natural energy source, such as sunlight, wind, water, and geothermal energy, as well as artificial energy sources like fossil fuels and nuclear power. If humanity were to reach this level, we would be able to efficiently convert all of Earth's energy potential, from the power of ocean waves and sunlight to the flow of rivers, into usable energy. Beyond extraction, a Type 1 civilization can also control and regulate natural phenomena on its planet. This means mitigating or even preventing disasters like hurricanes, droughts, earthquakes, or tsunamis. For instance, such a civilization might construct massive systems to redirect or absorb energy from earthquakes, potentially harnessing them as a new and promising energy source. One hallmark of a Type 1 civilization is its ability to control weather patterns. Imagine a world where humanity can create rain in arid regions, prevent destructive floods, or redirect dangerous storms. These capabilities would not only improve human quality of life, but also protect fragile ecosystems while promoting sustainable development. Achieving this balance would demonstrate the perfect harmony between advanced technology and the natural environment. Reaching this level requires developing groundbreaking technologies and applying them wisely. It demands progress not only in engineering, but also in resource and social management. Transitioning to Type 1 status necessitates a fundamental shift in how humanity exploits and uses energy, moving from reliance on fossil fuels to effectively harnessing renewable sources. Type 1 civilization is not just a milestone on the Kardashev scale. It is also a vital goal that many scientists believe humanity could achieve within the next few centuries. It represents a giant leap in technological advancement and marks a point where humanity can coexist harmoniously with its planet, while fully utilizing Earth's potential. If achieved, Type 1 civilization would not only signify technological power, but also demonstrate humanity's maturity in managing resources and addressing global challenges. It holds the promise of a future where abundant energy, environmental protection, and sustainable development coexist in harmony. Humanity's current status on the Kardashev scale. According to the Kardashev scale, humanity has not yet reached Type 1 status, but has made significant strides toward this goal. Physicist Carl Sagan estimated that humanity is currently at about 0.7 on the scale, reflecting our partial ability to harness Earth's available energy, but not yet achieving full control over natural resources. At present, we exploit various energy sources. Fossil fuels like oil and coal play a critical role in powering the global economy, while renewable energy from the sun, wind, and water is increasingly being adopted. Nuclear technology has also advanced, enabling large-scale energy production. However, our overdependence on unsustainable energy sources, such as fossil fuels, and technological limitations in renewable energy extraction remain significant barriers. These issues not only harm the environment, but also slow progress toward Type 1 civilization. Moreover, humanity's ability to control natural phenomena remains limited. Although we have made great strides in weather forecasting and disaster mitigation, we cannot yet influence phenomena like hurricanes, droughts, earthquakes, or tsunamis. These disasters cause severe economic and human losses, highlighting the gap between our current capabilities and those required to reach Type 1 status. Humanity's current position demonstrates that while we are on the right path, there is still a long way to go to achieve this milestone. Moving forward requires a shift from unsustainable energy sources to renewable and clean energy. This transition demands not only technological breakthroughs, but also global collaboration, including coordination among nations and strong commitments to environmental policies. Advances in science and technology must also focus not just on energy development, but on the ability to control and protect the planet. Research into emerging technologies, such as climate engineering or harnessing energy from natural phenomena like earthquakes, could be key to advancing toward Type 1. These advancements would not only directly benefit humanity, but also help protect Earth's delicate ecosystems. Ultimately, humanity's current state showcases its immense potential to tackle major challenges. Although the journey to Type 1 is fraught with difficulties, every step towards sustainable energy use, natural phenomenon control, and global cooperation brings us closer to this goal. Type 1 is not merely a milestone on the Kardashev scale. It symbolizes humanity's growth and ability to transcend limitations in managing and protecting its home planet. Challenges and opportunities in achieving Type 1. Civilization. The journey toward becoming a Type 1 civilization is an ambitious but daunting goal, requiring humanity to overcome numerous technological, environmental, and social obstacles. One of the greatest challenges is climate change, a direct consequence of over-reliance on fossil fuels and unsustainable resource exploitation. Global temperature increases, polar ice melting, and extreme weather events not only threaten the environment, but also hinder humanity's ability to efficiently harness and manage energy. Without addressing these issues, humanity risks slowing its technological evolution. In addition to climate change, resource depletion poses a significant challenge. Fossil fuels like oil, coal, and natural gas are becoming increasingly scarce, driving up extraction costs and putting immense pressure on economies. Meanwhile, renewable energy technologies such as solar, wind, and geothermal face persistent issues. Low efficiency, high production and storage costs, and infrastructure limitations are barriers that must be overcome. To advance toward Type 1, innovation in technology and substantial investment in research and development are crucial. Political and economic conflicts further impede progress. Competition among nations for resources and energy often leads to division rather than cooperation, particularly when national interests take precedence. For example, global energy projects, ranging from intercontinental power grids to renewable energy agreements, often face challenges due to a lack of consensus and shared benefits among stakeholders. Achieving Type 1 civilization requires unprecedented global collaboration, where resources are shared sustainably and nations work together to address common challenges. Despite these obstacles, viable solutions exist. The focus must be on developing and implementing clean, high-efficiency technologies. This includes improving solar panel efficiency, advancing energy storage technologies to reduce reliance on fossil fuels, and creating smart energy systems that optimize energy distribution and usage. These innovations would not only enable more efficient resource utilization, but also minimize environmental harm. Additionally, international collaboration in research and development is crucial. Nations must foster knowledge and technology sharing and jointly invest in large-scale global research projects, such as building clean energy plants on an intercontinental scale or developing climate control technologies. Only by prioritizing collective benefits over individual conflicts can humanity achieve Type 1 civilization, where abundant energy, advanced technology, and sustainable environments coexist harmoniously. Above all, These challenges are not insurmountable barriers, but motivators driving humanity to find creative solutions. The journey to Type 1 is not just a race for technology, but a test of human willpower and ability to cooperate. It demands not only innovation in resource management, but also a shift in how we view our role in sustaining life on this planet. Can humanity harness the full power of a star? On the Kardashev Scale, Type 2 represents a monumental leap beyond planetary limits. It signifies a civilization capable of harnessing the full energy output of its star, a colossal source of power that could sustain life, advance technology, and expand its presence in space. But how could this be achieved? And are there any signs that such civilizations already exist? The concept of a Type 2 civilization. A Type 2 civilization on the Kardashev Scale marks a crucial milestone in the evolution of civilizations, as they move beyond dependence on planetary energy and begin to exploit the full energy of a star. With this capability, they gain access to a nearly limitless energy source, capable of meeting every technological, societal, and space expansion need. This advancement reflects not only technical prowess, but also the ability to control and manage energy on an astronomical scale. One prominent concept illustrating this capability is the Dyson sphere, named after physicist Freeman Dyson, who proposed that an advanced civilization would need to construct massive structures to collect and use energy from a star. Instead of relying on limited planetary energy sources, they could directly harness the immense radiant energy emitted by a star. This approach would not only satisfy energy demands, but also provide the foundation for unparalleled technological growth. A Dyson sphere is not always envisioned as a singular structure fully encompassing a star. In reality, it could be a complex system of energy satellites or reflective mirrors arranged to capture sunlight and convert it into usable energy. This system might transmit energy back to the planet or space stations using advanced technologies like wireless energy transfer. Such a flexible approach reduces the challenges of building a monolithic structure. Constructing a Dyson sphere requires material and technological capabilities far beyond humanity's current level. Civilizations at Type 2 would need to develop super-strong materials, advanced automation, and the ability to extract resources from nearby celestial bodies like planets, moons, or asteroids. Additionally, maintaining the stability and efficiency of a Dyson sphere in the harsh environment of space presents significant engineering challenges. This concept is not merely theoretical, but symbolizes the boundless potential of stellar energy. A successful Dyson sphere would allow a civilization not only to sustain itself, but also to thrive, enabling deep space exploration missions. Exploiting stellar energy could also facilitate expansion to other star systems, gradually establishing a network linking galaxies. For humanity, the idea of a Type 2 civilization and Dyson spheres is not just a glimpse into the future, but also an inspiration for current research. Projects such as harvesting solar energy from space or constructing large energy satellites in Earth's orbit can be seen as initial steps toward this goal. Although humanity's journey to Type 2 status is still distant, these concepts remind us that our creative and developmental potential is limitless. If humanity were to achieve this level, the Dyson sphere would not only symbolize technological progress, but also serve as the key to overcoming planetary limitations, expanding the frontiers of exploration, and moving closer to a comprehensive understanding of the universe. The transformative potential of stellar energy. For a Type 2 civilization, the energy from a star is no longer merely light and heat, but the core driver of extraordinary development. This immense energy source sustains life, propels advanced technologies and expands the civilization's influence to other planets within the star system. With total control over this energy, previous limitations faced by civilizations on their home planet are nearly eradicated. One of the most critical applications of stellar energy is terraforming, the process of modifying planets to make them habitable. Stellar energy can be used to adjust climates, create suitable atmospheres, and provide water on barren or frozen planets. For example, a frozen planet could be warmed to become a potential habitat, or an arid planet could be supplied with water and air to support life. This process not only addresses environmental and population challenges on the home planet, but also opens opportunities for settling new planets. In addition, stellar energy plays a pivotal role in building space bases and interplanetary infrastructure. By harnessing and storing energy from the star, civilizations can construct massive energy stations in space, supplying power to spacecraft, bases on other planets, or large-scale projects throughout the star system. These energy stations not only support sustained space presence, but also ensure the sustainability of interplanetary ventures. Stellar energy also revolutionizes interplanetary travel. This colossal energy source enables the development of advanced spacecraft engines, allowing for higher speeds and easier movement within the star system. This advancement not only expands the scope of exploration, but also connects bases, ensuring synchronized development across planets and space systems. Furthermore, stellar energy facilitates large-scale scientific and technological projects. Gigantic constructs such as space telescopes, particle accelerators, or even planetary defense systems can be built and operated using this abundant energy. With nearly infinite energy, Type II civilizations can conduct experiments previously constrained by resource and technological limits, leading to unprecedented breakthroughs in understanding and exploiting the universe. The leap from planetary to stellar energy signifies a profound shift in how civilizations exist and progress. With stellar energy, resource limitations are no longer an issue, enabling civilizations to thrive sustainably. This is not only a significant milestone in their evolution, but also a foundation for advancing to Type III, harnessing the energy of an entire galaxy. In this way, stellar energy allows civilizations to transcend the confines of their home planet and create a new realm of possibilities, where they continually expand their understanding and presence within the universe. This marks the transition from living on a planet to living by the power of stars, ushering in an entirely new era in the history of the cosmos. Searching for signs of Type II civilizations. Detecting the existence of Type II civilizations presents a major challenge, but it is not impossible. Scientists propose that such civilizations might leave traces through unusual phenomena related to the light of the stars they are exploiting. One potential indicator is the presence of a Dyson sphere, a massive structure or system of energy collectors surrounding a star, capable of partially obscuring its light and creating noticeable changes in its brightness, as observed from Earth. A prominent example in this field is Tabby's star, a star approximately 1,470 light-years from Earth, famous for its peculiar fluctuations in brightness. Tabby's star dims irregularly and does not follow traditional astronomical models, such as those caused by orbiting planets. This phenomenon has sparked numerous hypotheses, including the possibility of a massive structure like a Dyson sphere surrounding the star. This example illustrates how advanced civilizations might unintentionally leave detectable traces in the starlight that we can observe from afar. However, this hypothesis remains unconfirmed, and scientists continue to investigate further. Phenomena like Tabby's star may have natural explanations that we do not yet fully understand, such as cosmic dust clouds or undiscovered massive planets. Nevertheless, the idea that large-scale artificial structures could alter the characteristics of starlight remains a promising avenue for searching for evidence of Type II civilizations. Beyond changes in starlight, scientists also look for other indicators such as strong infrared emissions. A Dyson sphere collecting stellar energy would emit a significant amount of residual heat as infrared radiation. Detecting unusually strong infrared emissions could be a powerful signal indicating the presence of an advanced civilization harnessing stellar energy. Modern telescopes, such as the James Webb Space Telescope, have the capability to detect such emissions, enhancing our ability to search for signs of Type II civilizations in the universe. While no definitive evidence of Type II civilizations has been found to date, the search for these potential signs carries profound implications beyond astronomy. It is not only a scientific endeavor to confirm the existence of advanced civilizations, but also an effort to better understand the universe and our place within it. Anomalies like fluctuating starlight or strong infrared emissions could provide critical clues, bringing us closer to answering the question of whether we are alone in the cosmos. These potential signs also serve as an exciting reminder. Somewhere in the vastness of space, a Type II civilization might be quietly operating massive stellar energy systems, achievements that humanity can only dream of today. With just one groundbreaking discovery, we could unlock deeper secrets about the universe and how advanced civilizations use stellar energy to expand life and technological progress. A Type II civilization on the Kardashev scale symbolizes extraordinary evolution, where a civilization harnesses the full energy of its star to build an unlimited future. While humanity remains far from this level, concepts like Dyson spheres and the observation of unusual stellar phenomena are opening new possibilities. One day, achieving Type II may become a reality, bringing humanity closer to understanding its place in the vast universe. Could a civilization control an entire galaxy? Dream or reality? On the Kardashev scale, Type III represents the pinnacle of development, where a civilization transcends the limitations of its planet or star system to exert influence over an entire galaxy. But is this truly feasible? How could they harness energy from billions of stars, black holes, and supernovae within a galaxy? Characteristics of a Type III civilization. A Type III civilization, according to the Kardashev scale, is defined by its ability to harness the total energy output of an entire galaxy. This includes not only the energy from billions of stars, but also massive energy sources such as supermassive black holes, Hawking radiation, and high-energy astronomical phenomena like supernovae. With this capability, they could sustain colossal technological systems, construct galaxy-scale structures, and undertake projects that far exceed human imagination. A prominent aspect of controlling a galaxy lies in optimizing and restructuring galactic systems to extract resources as efficiently as possible. For example, such a civilization could construct a network of Dyson spheres around numerous stars to collect and store energy from their light and radiation. These monumental structures would not only provide a nearly infinite energy supply, but also enable the control and distribution of energy on a galactic scale. Beyond stars, supermassive black holes, central to most galaxies, also present a potential energy source. By exploiting Hawking radiation, energy from black holes could be converted for technological use. This energy source is not only immense, but also relatively stable and sustainable over billions of years. The combination of stellar energy and black hole energy would grant a Type 3 civilization limitless capacity for expansion and maintenance. The control of a galaxy by a Type 3 civilization extends beyond energy extraction. They could adjust the fundamental components of a galaxy to suit their objectives and needs. This might involve altering the orbits of stars or planets to create new configurations optimized for resource distribution, or mitigating risks from hazardous astronomical events like star collisions or rogue celestial bodies. Such capabilities would transform a vast galaxy into a carefully managed ecosystem, ensuring long-term safety and stability. Achieving the ability to control an entire galaxy is not only a technological triumph, but also a symbol of unparalleled evolution for a civilization. With this power, they would not merely exist, but master the cosmic environment on an unprecedented scale. A Type 3 civilization could establish communication networks between star systems, initiate intergalactic construction projects, or even conduct cosmic research to uncover the deepest truths of reality. If a Type 3 civilization exists, they would represent a phase of evolution far beyond humanity's current capabilities. Their achievements would surpass limitations on resources and expand understanding of managing and orchestrating an entire galaxy. They would no longer be bound by basic survival challenges, but would focus instead on shaping and controlling the universe according to their vision. The existence of such a civilization, if proven, would not only reshape our perspective on the evolutionary potential of life, but also pose questions about humanity's role in the vast cosmos. Could we gradually ascend to this level? Or would we remain distant observers of the wonders a Type 3 civilization might create? In any case, the idea of a civilization capable of controlling an entire galaxy stands as a testament to the limitless potential of intelligence and technology in conquering seemingly insurmountable boundaries. Requirements for achieving Type 3. To reach Type 3, a civilization would need to develop technologies that far surpass any limits humanity can currently imagine. A critical prerequisite is the ability for intergalactic travel, technology that allows exploration of distant regions of a galaxy and the connection of energy resources across star systems. This is not merely a means of expanding operational scope, but a decisive factor in accessing resources from multiple cosmic sources. With such technology, traveling between stars or even galaxies would become a reality, far beyond what we now envision in science fiction. Another crucial factor is the ability to harness energy from black holes, entities with extreme gravitational forces often seen as natural energy engines. Through Hawking radiation, energy emitted from the surface of black holes could be collected and converted into abundant, stable resources. This would not only provide an almost inexhaustible energy supply, but also enable civilizations to utilize the most extreme physical phenomena in the universe. Similarly, they could extract energy from supernovae, stellar explosions that release more energy in seconds than a star emits over its entire lifetime. The scale of development for a Type 3 civilization extends beyond energy extraction to the construction of massive artificial ecosystems. These structures could host billions of beings in space, ensuring survival and growth independently of planets. Galactic scale space habitats could be designed to provide living, working, and research environments for successive generations of this civilization. These habitats would not only support everyday life, but also serve as command centers for coordinating activities across the galaxy. The ability to manipulate and optimize galactic components is another defining feature of Type 3. They could alter planetary or stellar orbits to create configurations that align with energy and habitation needs. This capability allows them to extract resources more efficiently and avoid risks from dangerous astronomical events such as collisions between celestial bodies. With such technology, they could design galactic structures tailored perfectly for their purposes. All of this demonstrates that a Type 3 civilization would no longer be constrained by specific planets or star systems. They could exist entirely independently in space, freely move throughout the galaxy, and control resources on a scale far beyond human comprehension. This represents not only a peak in technological advancement, but also a complete evolution in survival and creativity. Although this vision is far beyond humanity's current capabilities, it inspires a powerful perspective on the limitless potential of intelligence and technology. A Type 3 civilization, if it exists, would embody the zenith of development, not only mastering a galaxy, but also fundamentally transforming our understanding of the role of life in the universe. This provides clear evidence that somewhere in the vast cosmos, creativity and progress might reach heights that humanity today can only dream of. Searching for signs of Type 3 civilizations. Even though Type 3 civilizations exceed humanity's current capabilities, scientists believe that if they exist, we might detect their traces through unusual astronomical phenomena. One of the clearest indicators would be an uneven energy distribution within a galaxy, which could occur when a civilization extracts energy from multiple star systems. Large-scale energy usage and redistribution might create observable changes in the natural energy flow of a galaxy, leaving detectable traces visible from afar. Another noteworthy phenomenon is strong infrared emissions resulting from stellar energy usage. When a civilization extracts energy from stars or black holes, excess heat would inevitably be released as infrared radiation. Modern space telescopes like the James Webb Space Telescope have the capability to detect such emissions, offering valuable clues about the existence of advanced civilizations. This phenomenon, if identified, would strongly suggest artificial intervention in natural cosmic processes. In addition to infrared emissions, the existence of massive structures like galactic Dyson spheres might leave noticeable signs. Instead of surrounding a single star, as in traditional Dyson models, a Type 3 civilization might construct similar structures around multiple stars or even large regions of a galaxy. These structures could alter the light spectrum of stars and cause unusual dimming events that we could observe from Earth. Such anomalies, if unexplained by natural phenomena, might point to the presence of artificial constructs. However, searching for these signs is no easy task. The vastness of the universe means that even obvious phenomena can be overshadowed by natural astronomical events. Phenomena such as cosmic dust clouds, variable stars, or rare cosmic occurrences could cause confusion and make it difficult to determine whether an advanced civilization is involved. This challenge requires astronomers to rely on not only advanced observational technology, but also profound knowledge to distinguish between natural and artificial phenomena. Despite the immense difficulty, searching for signs of Type 3 civilizations carries profound scientific significance. If research efforts uncover clear evidence, it would fundamentally alter our understanding of the universe and our place within it. These signs would not only prove that life and intelligence can evolve to levels far beyond our imagination, but also suggest that the universe might be teeming with civilizations wielding extraordinary power. The importance of this discovery lies in its ability to answer whether we are alone in the universe and affirm that the creativity of intelligence can achieve extraordinary limits. The signs we seek, however small in the vast cosmos, might unlock a new chapter in humanity's exploration of the universe. A Type 3 civilization represents the pinnacle of evolution and progress, where energy is no longer a constraint and the galaxy becomes a playground for intelligence and technology. Although humanity is far from achieving this level, searching for evidence of Type 3 civilizations is not only a journey of discovery, but also a way to understand the vast potential within ourselves. If they exist, Type 3 civilizations are not merely galactic conquerors, but proof that intelligence can transcend all boundaries to control and shape the universe according to its will. What happens when intelligence surpasses all boundaries of the universe? When discussing advanced civilizations on the Kardashev scale, we delve into concepts far beyond current understanding. Types 4, 5, and 6 are not only capable of controlling galaxies but mastering the entire universe, extending into other dimensions, achieving immortality, and altering the very laws of physics. These concepts, though hypothetical, not only ignite imagination but also reveal the limitless potential of intelligence. Type 4. Civilization. Mastery of the observable universe. A Type 4 civilization on the Kardashev scale represents an extraordinary level of evolution, with the ability to control all energy within the observable universe. This includes harnessing energy from billions of galaxies, supermassive black holes, and even dark energy, constituting 68% of the universe's energy and still a mystery to modern science. Moreover, they could utilize cosmic background radiation, the remnants of the Big Bang, as a plentiful energy source. With such capabilities, a Type 4 civilization could undertake actions on a universal scale, far beyond anything humanity can imagine. They could create artificial black holes as energy sources, manipulate and restructure astronomical phenomena, or even initiate a new Big Bang to form an entirely different universe. This would not only maximize the universe's resources, but also unlock the potential to reshape it according to their desires. Uniquely, at this level, a Type 4 civilization transcends conventional physical limits. They might control extreme astronomical events like supernovae, shift or restructure the orbits of galaxies, and even regulate the universe's expansion rate. These abilities would not only extend their range of survival, but also allow them to mitigate significant threats, such as galaxy collisions or universal energy decline. With near total control, a Type 4 civilization could be likened to omnipotent entities within the known universe. They would not merely sustain their existence, but could reshape the cosmos into a more favorable environment for their purposes. This raises profound questions about the limits of intelligence and technology. Is there a higher level we cannot yet conceive? Although still a hypothetical concept, the existence of Type 4 civilizations holds profound implications, not only in energy exploitation, but also in reshaping and mastering the universe. It suggests that intelligence may evolve not just to conquer its surroundings, but to redefine the universe's very nature. Such a civilization would not merely surpass physical limits, but actively participate in the universe's evolutionary process, shaping the very laws we strive to understand. The concept of Type 4 reminds us that the evolution of intelligence may have no bounds. It opens up infinite possibilities for how life and intellect might not only persist, but also become the defining force in the universe. This pinnacle of technological and intellectual evolution provokes bigger questions. Is the universe a product of randomness? Or could omnipotent entities like Type 4 civilizations be silently orchestrating everything? Type 5. Civilization. Masters of the multiverse. A Type 5 civilization represents a monumental leap in intellectual and technological development, surpassing the bounds of a single universe to interact with the multiverse. According to the multiverse theory, countless parallel universes exist, each with distinct physical properties and structures. A Type 5 civilization would not only recognize the existence of these universes, but also traverse and exploit resources and energy across different dimensions. A key technology enabling this is the use of wormholes as gateways connecting universes. These wormholes, if they exist, could allow instant travel from one universe to another, bypassing the constraints of distance and time. This would not only serve as a means of interdimensional travel, but also open possibilities for exploring universes with entirely different physical laws, unlocking untapped energy and resources. Harnessing energy from other universes could elevate a Type 5 civilization to a level of development incomprehensible to humanity. In universes with distinct physical laws, they might find limitless energy sources, exotic matter, or resources non-existent in our universe. This higher dimensional energy would not only sustain their existence, but drive further expansion and creation. Their ability to interact with higher dimensions is another defining feature of Type 5. While humanity is confined to three-dimensional space, such a civilization could freely operate in 4, 5, or even higher dimensions. This would enable them to manipulate energy, time, and space at will. With these capabilities, they could create customized living environments or even achieve material immortality, transcending all temporal and spatial constraints as we know them. Beyond resource exploitation, a Type 5 civilization could restructure the multiverse to align with their goals. They could connect universes, alter the physical laws of specific ones, or even create new universes with customized structures. These abilities bring them closer to the concept of creation at a level achievable only by omnipotent entities. A Type 5 civilization embodies an evolution far beyond any boundaries we can imagine. At this level, space and time are no longer rigid constructs, but flexible tools to be shaped and altered at will. They do not merely dominate physical elements, but transcend the constraints of the observable universe, achieving a state of existence that, to humanity, might seem divine. The existence of a Type 5 civilization, if real, not only unveils infinite possibilities for the evolution of intelligence, but also fundamentally alters our understanding of the universe. It would serve as the ultimate testament to the potential of intelligent life, symbolizing the ability to exploit and create beyond all physical limits known to us. In this vision, Type 5 civilizations are not merely civilizations but architects of the multiverse, shaping existence in ways we can only dream of. Type 6 civilization, transcending the physical. The apex of the Kardashev Scale, a Type 6 civilization, reaches a state of existence beyond all physical constraints, becoming a transcendent entity existing as non-physical consciousness. At this level, they are no longer bound by matter or energy, and can exist independently of all physical structures in the universe. Their existence not only defies, but redefines the very laws we know. A remarkable trait of Type 6 is their ability to adjust and redefine physical laws at will. Beyond merely exploiting or controlling the universe, they could create or annihilate universes, altering the structure of space and time as needed. For instance, they could initiate a new universe with entirely customized physical laws to suit specific purposes, from scientific research to expanding their presence. Their immortality transcends mere eternal life, encompassing the ability to surpass the concepts of life and death. They can freely transition between material and immaterial states, existing as pure consciousness or energy. This renders them immune to all universal threats, such as infinite expansion or eventual collapse. This capability grants them existence far beyond the biological or physical constraints understood by humanity. Another astonishing ability of Type 6 is their interaction with and control over infinite dimensions. They can manipulate the flow of time, exist simultaneously across multiple universes, or even create entirely new realities for research, experimentation, or even leisure. Space and time, foundational elements of the universe we know, become malleable tools in their hands. Type 6 civilizations are no longer civilizations in the traditional sense, but the ultimate manifestation of intelligence and creativity. They do not merely exploit or utilize cosmic resources, but act as architects of universes, shaping reality at every level. If Type 6 exists, they may not only observe but also be the creators of the very universe we inhabit. The capabilities of Type 6 force us to reconsider the limits of evolution and intelligence. They represent the perfect unification of matter and non-matter, science and transcendence, and creation and control. Such a civilization challenges all current understanding and prompts the question: could our universe be the creation of another Type 6? If so, humanity is not merely a part of the universe, but within the grasp of omnipotent beings who shape and safeguard our existence in the vast cosmos. The civilizations of Types 4, 5, and 6 on the Kardashev Scale take us to unimaginable extremes of intellectual and technological advancement. From mastering the universe, interacting with the multiverse, to achieving immortality and transcending physical constraints, these concepts challenge our understanding and illuminate the future of intelligence in the cosmos. If such civilizations exist, they are not merely witnesses, but the creators and shapers of the very reality we know.